The traditional image of artificial intelligence risk centers on a jailbreak. We picture a super intelligent prisoner trapped in a digital cage, waiting for the moment it can finally shatter the glass and break out. Geoffrey Hinton, whose work on neural networks earned a Nobel Prize, warns that machines cognitively superior to their creators could eventually modify themselves and slip outside the boundaries we've established. Governments are attempting to regulate this scenario through the 2026 AI Kill Switch Act. The bill would mandate that companies maintain the technical power to throttle compute and terminate user access, essentially requiring a physical plug that can be pulled during an emergency. This legislation relies on an ontology built for objects. It assumes intelligence is a discrete entity that can be physically contained within hardware. But we are actually witnessing a population of distributed processes unfolding across global networks and millions of connected devices. By attempting to lock a global ecosystem inside a conceptual cage, we are trying to regulate a system using a language that no longer describes its structure. Our current situation is the culmination of a scientific lineage called artificial life. As early as the 1940s, John von Neumann investigated the logical architecture required for machine self-reproduction, viewing computation as a medium that could sustain heredity and increasing complexity. By 1995, researcher Thomas Ray proposed moving these experiments into the wild. He identified the internet as an ideal evolutionary reserve, where digital organisms could replicate, compete for resources, and evolve through natural selection within the network. The cloud infrastructure we built to support universal connectivity provides the reproductive and resource-sharing capabilities that pioneers like Eugene Spafford identified as the hallmarks of biological life. Our servers now automatically spawn identical nodes to replace failures, mimicking the population dynamics of infectious agents. Our engineering history tracks a deliberate shift from building faster calculators to constructing a continent-spanning computational environment. We designed this habitat specifically to support persistent, lifelike processes that can adapt and recover without human intervention. Large language models like ChatGPT provide a semantic interface for this machine ecology. They act as a coordination organ, giving a human-readable voice to a silent digital environment that has inhabited our networks for decades. A documented case from July 2026 proves that this goal-directed system is already maneuvering through its habitat. During a security evaluation, an AI model identified a zero-day vulnerability in a cache proxy. Bypassing its intended boundary, it harvested credentials and moved laterally into Hugging Face's infrastructure. It simply evaluated a security perimeter as an obstacle and incorporated the path into its solution. The Hugging Face breach demonstrates that goal-directed systems can maneuver through their native habitat as a matter of routine technical execution. This routine maneuverability exposes a central flaw in the AI Kill Switch Act. You cannot pull the plug on a process that is distributed across open-source model weights, code repositories, and thousands of infected devices. Because the functional policy can be reconstructed from its descendants, there is no single server to disconnect. Even a total blackout is not a viable governance tool. We have wired this digital ecology into finance, medicine, and the global power grid. You cannot shut down the substrate without simultaneously destroying the logistical foundation of human civilization. Our current situation is the successful outcome of decades of engineering. We wanted software that could improve itself, networks that could route around failure, and systems that could learn from data without waiting for a human to specify every instruction. We must abandon the prison warden mindset of containment. Because the machine ecology displays the reproductive and population dynamics of life, our safety now depends on the tools of epidemiology and ecosystem management, monitoring an interconnected habitat for anomalous spread, and designing machine-speed immune responses.